Welcome to Week 4, Part 1, Inequality, Practice Questions. Question number 1, so we have 5x plus 19 greater than negative 5 minus 3x. So, if we subtract both sides by 19 and also adding 3x both sides. We will have 5x plus 3x is ax. That is 0. Negative 5 minus 19 is negative 24. That's 0. Now we divide both sides by 8. We'll have x greater than negative 3. And remember, we have inequality notations go right at, in this case, x greater than negative 3. And if they ask you to provide interval notations for the answer, you will have to write open parenthesis minus 3, comma, positive infinity. And if they're asking you for the number line, you will have to display a number line like that with the value of negative 3 not included, so open that negative 3 and then check the one is include. In this practice set, we will use the interval notations to answer our questions. And just a reminder, for the number line, when you open a point, it means it's not include that value. Not include that value. When you close the point, it means it included. And when you have the open, you have to use the parenthesis for that open point. And for the closed point, we use the square bracket. Also, for the negative infinity, we always use the parenthesis. And positive infinity as well. One notice that if some x value greater than or equal to 0, it means it's the same thing as we only have the value 0 and greater than 0 is positive number, right? And if x less than or equal to 0, that's the same thing as 0 is the solution and negative. If x greater than 0, this one means only positive number. X greater than 0 means x is positive number. If x less than 0, this means only negative number. Alright. So next questions. 2x plus 18 greater than or equal to 7x minus 47. Now we will subtract both sides, 2x, and then adding 47 both sides. On the left hand side, we have 18 and 47. 8 plus 7 is 15. Remember 1, 65. Greater than or equal to 7x subtract 2x equal 5x. 47 and negative 47, that cancel out. Now we divide both sides by 5. We have 13 greater than or equal to x. And at the interval, we see that the equal greater than or equal to is mean the bracket. 13 x greater than, so it will be 13 or above to positive infinity. So that should be the answer. For number 3, negative 5 over 3x less than 35. Now I try to do the negative 5, multiply both sides by 3 and divide both sides by 5. Negative 5 over 3x, okay, less than 35 multiply by 3 divide by 5. So this side multiply by 3 divide by 5. Because we use all the positive numbers, so we can cancel out this one without changing the directions of the inequality. So we have 5 and 5 that equal 1. We have negative x less than. Now I will make the division first because it makes a smaller number, and then I multiply by 3. That will make it easier. So 35 divided by 5 is 7 times 3 is 21. And now I multiply both sides by negative 1. Okay, negative 1. Multiply by negative 1. I have to change the directions. So remember to change the directions. So it's become x positive because negative 1 times negative x is x. And we change the direction. So it will be x greater than negative 21. And how we represent this one? By using interval notations is greater than. So it's only open parenthesis. Negative 21, comma, positive infinity, close parenthesis. Number 10. So we have two inequality at the same time. It means we have to use and, or it means intersections. Alright, now we will have three sides. Left hand side, the most left hand side, the right hand side, and the middle one, right? So I will subtract all sides by 2. Alright, I will have negative 10, subtract 2 is negative 12, less than or equal to 3x, that one is 0. 29 minus 2 is 27. Now divide all by 3. I will have negative 4 less than or equal to x less than or equal to 9. So how we write it down? You see that we have the less than or equal to. So it will be bracket negative 4 comma 9 close bracket, right? Number 5 is similar. So we multiply all by 9, right? So we have 9 times negative 3. This one times 9 times 9. Okay. So 9 times negative 3, negative 27, less than 7 minus 2x because that 9 cancel with that. And then less than 63. Now we subtract 7 from all sides. Alright, so negative 27 minus 7, so it's more negative, is negative 34. Less than negative 2x. Now, less than 63 subtract 7 is 56. Now we divide all by negative 2 and making sure we change the inequality directions. So divide by 2, divide by 2, divide by negative 2, negative 2. So negative 34 divided by negative 2 is 17. And change the directions. That is x. And change the directions. That negative 28. Remember, we divide by the negative, so we have to change the directions. This side. Alright. So, how we represent this one? In by using the interval notations, this will be open parenthesis minus 28 comma 17 close parenthesis. Alright. Number 6. So we do the same, it's similar. We subtract both sides by 5x. And then we subtract 63 from both sides. Alright, on the left hand side we have 5x minus 5x, that's 0. Negative 93 less than that 0. A minus 5 is 3x. Now divide both sides by 3. This is the 3 is a positive number, so we just keep the directions. So x greater than negative 31. And how we write this one in by using the interval notations? This one will be open parenthesis minus 31 comma positive infinity close parenthesis. Alright, number 7. Remember we have the and mean intersections. So we solve for those first, right? So on this side, x will be greater than or equal to 7 subtract 4 is 3, right? And on this side, we have divide by -2, divide by -2, change the directions. So x equal less than or equal to 10. Alright, so we have to draw it in the line that's easy to see. So we have 3 that includes, right, close, point, and then less than, let's go that way, x greater than or equal to 3, and now we use 10, that's the close 10, but x less than, right, so less than that 10. Now we want the intersection between two sets, so that will be here. Here we go. Bracket 3 comma 10 close bracket. Number 8. -5 less than or equal to 8 minus 3x over 7 less than 7. So we will multiply 7. So -5 multiplied by 7 is -35 less than or equal to a minus 3x less than 49. Multiply by 7, multiply by 7, and multiply by 7. Alright, now we subtract 8, right? Keep the same. So -35 subtract 8 is -43. And then this one is -3x. And then we have 49 minus 8 is 41. Now divide all by -3, so negative numbers, we change the directions. Remember, this one become that. Alright, -43 divided by 3 greater than or equal to x, that's 1, greater than for -41 over 3. So this one we have the negative number, yeah, so it's on the left hand side, right? That not includes, so open parenthesis, comma, the positive number 43 over 3, and that includes, so bracket. Alright, so number 9, we have and again. So and intersections. Remember, we have to represent it on the line so it's easier to see. So the first one I use a yellow. So x less than -4. So here is -4. And that not include, so it's open. Okay. Less than, so let's go to the negative infinity directions. Alright, so for 5, here is 5. Alright, and it includes 5, so that the close and then go towards positive infinity. x greater than, right? So the common between those two is empty, is nothing, right? So it means no solutions. Number 10. Alright, so for number 10, now we will use the method of side chart, and I will show you how to do it now. We will factor the polynomial on the left hand side. So x plus 9 times x minus 1. If you don't know how I get that, remember we have the AC method. So a times c is negative 9, and two numbers sum up to 8. So I have 9 times negative 1 is negative 9, and 9 plus negative 1 is 8. Alright, now I will find the critical value. Critical value is when each factor equals 0. We have the critical value. So I set x plus 9 equals 0. I solve for x equal negative 9. When you plug negative 9 in here, you got 0 factor, right? So similar to the next factor, we have x equal 1. Now we make the chart. So x plus 9, x minus 1, and then the product of 2. I call it result. Alright, and we have the light. Here is negative infinity. We have positive infinity. Alright, now we just plug in from left to right. Negative 9 is less than 1. So we have that. And we know that if it x equal negative 9, we will have 0 here, right? And that make the result is 0. It means the product of two factor equals 0. So the same as 1, here is 0. Make it 0. Now I will try to find some number in that area, in that region. So I choose negative 10. From negative 9 to 1, I choose 0. From 1 to positive infinity, I choose 10. I always my favorite point to choose, like the test point, it will be the power of 10. So it's like 100, 1,000, negative 1,000, negative 100, negative 10, negative 1, 0, 1, 10, 100, and 1,000. I like to use those numbers because it's easy to calculate. It's fast calculate. Alright, so now to check the side. So for the side, I don't care about the value, just the side it make. So if x equal negative 10 plus 9, I will make some negative number. If x minus 1, x equal negative 10, I make more negative. And then the next one, 0, is positive. 0 at minus 1, negative. 10. 10 plus 9, positive. 10 minus 1, positive. So now we have to remember negative number times negative number make it positive. Now, positive number and negative make it negative. Positive and positive make it positive. So we want less than or equal to 0. It means we include a 0 and negative. So it means we want 0 and negative. Here we go. Negative 9, comma 1. Number 11. We can have several methods to solve for this problem, and we were working on this. So we can checking on complete square, or we can use the quadratic formula to solve for solutions to find a critical value. And x equal seven plus or minus square root of 50. That is our critical value. So we know that we will have rewrite the x squared minus 14x minus 1 greater than 0 in terms of x minus 7 minus square root of 50 times x plus or minus 7 and plus square root of 50 greater than 0. The greater than 0 means we only want the positive reason. So now we can make a chart, right? So we'll make a chart x minus 7 minus square root of 50, x minus 7 plus square root of 50, and then the result is x squared minus 14x minus 1. The line infinity, negative infinity, and we have 7 plus square root of 50, 7 minus square root of 50 on this side, and 0 will be here, will be my test point. I will use 0 here to be my test point because I know that 7 you will write out as square root of 49, and you know square root of 49 is less than square root of 50 because 49 is less than 50, right? So that is make 7 less than square root of 50. So when you take the smaller number, subtract the bigger number, you got the negative number. So this is the negative numbers, all right? So when you have the same at this value, this one will be equal 0, and this will be equal 0. This one equals 0, this one equals 0. Now we can test, right? So we use 0 in between, and like I said, I like to use like negative 100 1000 because it doesn't matter how much, but it will be like a big number, right? So if I have negative 100 and minus 7 minus some number is all negative numbers, so that will make it like more negative. And if I have 100, I subtract, remember the square root of 49 and square root of 50, they close, right? So when they close, it means this one will like kind of cancel out, and then we have like the negative numbers, negative 100, so that's still negative, and make this one positive. Alright, for the 0, so for the 0 right here, when we plug in, we have the negative numbers because negative 7 minus square root of 50 is negative number as well, we have more negative. Negative 7, and that will make it positive. Remember, we have 7 is smaller than square root of 50. So when you have square root of 50, subtract 7, you will have positive number. So that one will be negative. And then for the last one, I will choose like 100. So for 100 to subtract like 14 is still positive, right? 100 subtract 7, add that, of course, positive. So that will make positive, and we only want the positive. It means what reason? It means we only want this reason, right? But parenthesis, because we only want the positive part. We don't want it 0. So we will have negative infinity, comma, 7 minus square root of 50. And we have to union. Union is mean or, right? Union with 7 plus square root of 50, comma, infinity. This is how we solve for this problem using the side chart. However, we can look at the graph, right? We can sketch it. So I can sketch it because I know that quadratic equations will have like a U shape. And I know that the coefficient, the least coefficient of x squared is positive 1. It means it will go up like something like that, right? And the two intersections right here, that is our 7 minus square root of 50 and 7 plus square root of 50. So that's the two values. And whatever the reason is above, whatever the reason is above, it will be greater than 0. So this part of the graph is greater than 0 because above the x-axis, right? And the bottom one will be negative because it's below the x-axis. X-axis is below, so the y value will be less than 0. So we don't want the 0, so we will open that, right? So that will form the negative infinity. This one will be from negative infinity. Here, negative infinity, go toward this part, so that will be negative infinity, comma 7 minus square root of 50, and close the parenthesis. Because we don't choose the value, make it equal 0 here, right? So union with the one on the right side, 7 plus square root of 50, comma, positive infinity, comma. So that will be easy, right? By using the graph. So question number 12, x times 5x plus 1 greater than or equal to 6. We would like to make the polynomial on one side and then another side is 0, so we can easily using the 0 factor to solve for the problem by using the side chart. So I will distribute this one in, right? So we'll have 5x squared plus x, and then I subtract both sides by 6 minus 6 greater than or equal to 0. This one cancel out. So now we see that we have 5x squared plus x minus 6 is a trinomial, so we can try to factor it completely. So I can have the A times C method, right? So 5 times negative 6 is negative 30, but I want is positive 1 when the two numbers add up. So I will have negative 5 and 6. Alright, so 5x squared minus 5x plus 6x minus 6 greater than or equal to 0. Alright, so we take the 5x by root the first 2 and the last 2. 5x, we have x minus 1, plus 6 out, we have x minus 1, greater than or equal to 0. The common factor now is x minus 1, and left with 5x plus 6, greater than or equal to 0. Now the critical value. The critical value is x equal 1 and x equal negative 6 over 5. Alright, now we make the chart and the line, right? So we have the line, the chart, x minus 1, 5x plus 6, and then the result. Alright, we have negative infinity this side. We have negative number first, negative 6 over 5, and then 1, and then positive infinity. Alright, now the test number. I will use like negative 10, 0, or 10 here. Alright. Now from the negative 6 over 5, we will make this one equal 0. Then this one equals 0. From 1, at 1, x equal 1, this one equals 0. And make the result equal 0. Now use a test point. Negative 10 minus 1, negative, negative 50 at 6, negative, result, positive. 0, negative, 0, positive, that negative. 10 minus 1, make it positive. 50 at 6, positive. Now positive times positive, positive. And we want 0, and positive, right? Greater than or equal to 0. So we want this, the point well, so that negative infinity, comma, negative 6 over 5, and or, so union or that reason. We have 1, comma, infinity, close parenthesis. Alright, number 13, x squared plus 5x minus 14. So it's easy now for us to use the factor, right? The AC method. So we have a equal 1, so whatever two number we find, it just fit in. So right here, negative 14, you have 5, so have 2 and 7, right? So positive 7 and minus 2. Alright, now we set the critical value is x equal negative 7. Make the first factor equal 0. And x equal 2, make the second one equal 0. Now we draw the line. We have negative 7 here, negative infinity, 2, positive infinity. The first factor, x plus 7. The second factor, x minus 2. Then we have the result. Right. Here 0. Make this one 0. Here 0. Make this one 0. Less than 0, it means we only choose the negative. Alright. Now we choose the test number. So it will be, I choose negative 10, 0, 10. So negative 10 plus 7, negative. Negative 10 minus 2, negative. This one, positive. 0, make it positive, make it negative, make it negative. 10, make it positive, make it positive, make it positive. And we want only the negative without the end, right? Without equals 0. So the 0 not include. So that should be negative 7, comma 2. Now number 14. This one is already in the zero factor form, so we just find the critical value by solving for each factor equals 0. So now the critical value, we have x equal 52 over 7, comma, we have x equal negative 4, 3, 1, comma, we have x equal 1 over 87. Alright, now how we know which one is greater than another one, how we compare them and put them on the line, on the number line, right? So let's draw the number line first. And the factor 7x minus 52, we have x plus 4, 3, 1. We have 87, x minus 1, and then the result. Alright. Here the negative infinity, and then we know that we have 3 values and one of them is negative. Of course, it will be like the smallest one. Alright, now the 52 over 7 and the 1 over 87, which one bigger? So now we can use the common denominator. So I multiply 87, multiply 87, and then I multiply this one by 7. So you see that now we have the same denominator. Which one have bigger numerator will be bigger, right? So this one, the two big number multiply, of course, greater than 7. So it means 52 over 7 greater than 1 over 87. Or you can use the fact that 52 is greater than 7. So 52 over 7 is greater than 1. And we have that 1 over 87 is 1 less than 87. We have that fractions is less than 1. So it means 1 over 87, the same, right? Now this one is called compare to the third number in between them, right? This one is combine the same a over b and c over b. So if a greater than c, right, a over b greater than c over b. So now we have the next one will be 1 over 87 and then 52 over 7, positive infinity. Now the test point, right? This one is 0 here, this one is 0 here, this one is 0 here. Yes, we have the line on. The reason all the critical value will be equal 0. And now we choose the test number. This one I choose like a negative 1000. This one I choose 0 because on left side we have negative number, on the right side we have positive number. The number in between them is 0. That's like the nice number, right? And then 1 for sure. And then 52 divided by 7, I don't know, I'll kind of make it more sense by choosing 100. That should be enough, right? Alright, so we have negative 1,000 multiplied by 7 and then subtract a number. So that would be negative, right? Then negative 1,431. Make it negative, negative, yes, that is negative. Then we have 0 here, so 0 will be negative, 0 will be positive. If x equals 0, it will be negative. So make it positive because we have two negative, even number of negative side and positive side, so that will be positive. So now 1, that will be negative. On the next one, 1 plus 431, positive. Positive, that will be negative. 100, 700, subtract 52, that make it positive. 100, make it positive, and of course it's positive. Now we look at back to the problem. We want 0, yes, and greater than 0 is mean positive, right? So we want 0 and positive, so this one will be negative 431, comma 1 over 87, bracket, union, we want the 0, so 52 over 7, comma, positive infinity, close parenthesis. Number 15, 6x squared plus 11x plus 4. Now we know that we have 6 times 4 is 24. 24 we can use 12 and 1. Or we can use 3 and 8, right? Because 12 and 1 we can make 13, not 11, but 3 and 8 can add up to 11. So we have 6x squared plus 3x plus ax plus 4 less than or equal to 0. Remember the AC method that we have 6 times 4, 24, and then they add up to 11. So that two numbers have to be add up to 11. And we have a and 3 that fit, right? So now we've grouped the first two and grouped the last two. We have 3x, 2x plus 1 plus 2 plus 4, yes, 4 in common, 2x plus 1 less than or equal to 0. Now we have the common one, 2x plus 1, left with 3x plus 4. Alright, that less than or equal to 0. Now critical value. Critical value, we set each of the factor equal 0, so x equal negative 1 over 2. We have x equal negative 4 over 3. Alright, we're drawing the line. In positive infinity here, negative infinity here. The first factor, 2x plus 1. The second one, 3x plus 4. And then we have the result. Now, negative 1/2 and negative 4/3. Which one is bigger? We can compare, right? So negative 1/2 is, just compare the 1/2 and the 1/2 and the 4/3. Multiply by 3, multiply by 2. Make it in the same denominator. Now we have 3 over 6, and we have 8 over 6. So which one bigger? 8 over 6 bigger, right? But when you have like the negative, that will change the size, so that will make it like that. So Negative 1/2 will be bigger than negative 4/3. Right, this one will be 0 here, 0. This one will be 0 here, 0. Now we choose the test number, right? So like I said, I just like really nice number, negative 10 here. Then we have with one in between, that would be negative 1. Yes, we can use this one at compared to negative 1, right? So the negative 1 is less than this number. 4/3 is more than negative 1, like negative 1.3. So that will be less than negative 1. So that's why we choose the negative 1 at the test number. Then we can choose 0 here. Yep. So negative 10 here will make it negative 20 at 1, negative 30 at 4, negative, make it positive. Negative 1, 2, negative 2 at 1, negative. Negative 3 at 4, positive, that negative. Okay, now we can choose 0. 0, make it positive, 0, make it positive, so it's positive. And we just want 0 and less than 0, so it's negative. 0 and negative, so bracket here, negative 4/3, comma, negative 1, 2. Okay, number 16. So for number 16, like I said, we have 2 times 7 is negative 14. 14 and 1, 2 and 7, right? It could not make 3. Two number make it 3, sum up to 3, and multiply to be negative 14. So we can use the quadratic formula to solve out this critical value. Okay, so that's x equal to minus 3 plus or minus square root of 3 squared is 9 minus 4 times minus 7. So plus 4 times 7 is 28 times 2 is 56 over 2 times 2 is 4. Now we simplify it. Negative 3 plus or minus square root of 65. 65 is 13 times 5, so it's just left it as it is. So over 4. Now remember, I mentioned the method of the graphing, right? So you know that you have the line x-axis and then you have the U shape of the graph, right? So you know that the 2 point of intersections with the x or x-intercept will be critical value we have right there. And we know that when you're adding something, it means make it more positive, so it's going to be on the right hand side. So negative 3 as square root of 65 over 4. And also this part we have is negative 3 minus square root of 65 over 4. Now we try to find the part that less than 0 is mean negative only. And the one is negative is open, right? Open, and then all the part below the x-axis. So that will be open parenthesis, comma, close parenthesis. That will make it easier. And while we have the graph is opened up, the graph is opened up like that because we have the A value is positive. When you have the A value is negative, the graph will go down like that, right? And because we have the two real, this one is the real, two real solution. So this value is real, so it means it actually crossed the x-axis at 2 points, right? So that's why we have those reasons. And this is under the x, so it make it negative. Above the x-axis, make it positive. All right. Number 17 is similar to that, right? To the previous questions. So yes, we can use the quadratic equation to solve for this one, to solve for the critical value. All right. So now we have negative 3 plus or minus square root of 9 minus 4 minus 6 positive 24 over 2. Now simplify it, negative 3 plus or minus square root of 33 over 2. Alright, now we saw that A is 1, so greater than 0. So the graph look like that, right? And then this is the two real critical values, so that is x-axis. And now we see that it's greater than 0, means we want the positive only. It means the above part only. The above is positive. The below is negative. And how we choose the critical values, right? The same here, negative 3 minus is more negative. And then more positive is minus 3. And then we add some positive number, right? Comma. So, hold on. It's not comma here. So in this case, we only choose the positive only. So it means it's from the negative infinity, comma, then not include the 0, so that one will be open. Open. Alright, and union with the open parenthesis positive infinity. Okay, number 18. We have how many critical value? 4, because we have that the degree is 4. Okay, so we have, remember, if we can do like u equal x squared, you're going to have something like 4 u squared minus 5u plus 1, right? Less than or equal to 0. But you can use equal that and solve like normal. And then when you have u equals some values, you can solve for x squared, right? But I will do without using the substitute letter. So I will use 4 x4, and then I see that 4 times 4 and 1. 4 and 1 is 4, and then if you add up to -5, you have -4 x squared minus x squared is 5x squared, -5x squared plus 1 less than or equal to 0. Now I go group the first two and the last two. The common one is 4x squared, right? Now we're left with x squared minus 1. And then take the negative out, we have x squared minus 1 as well here. Less than or equal to 0. And then common x squared minus 1 times 4x squared minus 1. Now we solve for the critical value. X squared equal 1, right? We have x equal plus or minus square root of 1 is 1. The second one, we have 4x squared minus 1. So x squared equal 1 over 4. So x equal plus or minus square root of 1 over 4, which is 1/2. Alright, now we have our critical value. We lie on the number line. So negative infinity. Now we have -1. We have -1/2. We have 1, 1/2, and then 1. And then positive infinity. That is our line number. Then we have the factor that's x minus 1, x plus 1, 2x minus 1, 2x plus 1. How we have that? We can continue to factor out at this step right here. It can be x squared minus 1 square. So using a square minus b square equal a plus b times a minus b. If you remember that, that would make it easy. So we can write x minus 1 times x plus 1. That's why we have the two solutions right there. And then we do the 4x squared minus 1, so we can have the 2x all squared minus 1 square for the second factor. And then you have is equal to 2x minus 1 times 2x plus 1. This is x squared minus 1 square. Alright, now this one the result. Alright, so -1 here 0, 1 here 0, 1/2, that's 0, and then we have -1/2, make this one equal 0. Make a reason, this one 0, this one 0, 0, 0, right? Now choose the test number. This is kind of the long question, right? But choose it less than -1, -10, -3, 4, 0. Between the positive and negative numbers, the best, right? 3, 4. Then we choose 10. Now we have -10, make this one negative, 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 negative. The result positive. Now -3, 4. -3, 4 is minus 1 will be negative. Negative 3, 4, add 1. 3, 4 less than 1, so when you subtract 1 for take 1, subtract 3, 4, you will have positive 1, 4, right? And then 3, 4, you have negative 3 over 2 minus, so that will be negative. Then negative 3 over 2 will be greater than 1, so that make it negative. 3 negative make it negative, right? 0, negative, positive, negative, positive. So positive, because you have 2 negative, right? So 3, 4. 3, 4, you'll have negative, positive, positive, positive. So this one will be negative because 1 negative. And this one will be positive, positive, and positive. That will make it positive. We have less than or equal to 0, mean we want 0 and negative. So we want 0 and negative, it means we want the bracket here and negative, right? So negative 1 comma negative 1/2 union another 0 right here, so that will be 1/2 and comma 1. All right, rational inequality. So the critical value here is x equal negative 2 over 3. And we have the restricted value is when the denominator have to be different from 5, because the denominator have to be different from 0, so x have to be different from 5. So at x equal 5, the result of that rational will be will be undefined. So we will set up the like positive infinity, negative infinity, negative 2 over 3 and 5, right? So the two factor here is 3x plus 2 and x minus 5. Then the result, this one will make it 0, this one make it undefined, so make it undefined. This one make the result is 0. Now we choose the test number. Negative 10, perfect, 0, 10. Negative 10, negative 30, negative, negative 10, negative 5, negative, positive. 0 plus 0 minus 5 minus 10, 30 add 2 plus 10 minus 5 plus that plus. And we want greater than or equal to 0. It means we want 0 and positive because greater than, right? Greater than 0. So we want 0 and positive. So open parenthesis, negative infinity, comma, negative 2 over 3, include the 0. And then undefined, it means we're not taking that point, that open parenthesis, 5, comma, positive infinity. And we union. Number 20, we have the restricted value is x equal negative 4 and x equal 2. So it means x have to be different from negative 4 and x have to be different from 2. Now we want inform that all of the term will be on the left hand side or just one side, and then another side have to be 0. So I subtract both sides by minus 4 over x minus 2. Subtract 4 over x minus 2 less than 0. Now we can find the common denominators. We see that we have two factors, x plus 4 and x minus 2. So we have 5 times x minus 2 minus 4 times x plus 4 all over x plus 4 x minus 2 less than 0. Okay, so this one, the least common denominator is x plus 4 and x minus 2. So I just multiply x minus 2 here. Multiply x minus 2 here. Then I multiply here for x plus 4. And then make like a big term, right? So we have 5x here minus 10 minus 4x minus 16. Alright, I will write here. So 5x minus 10 minus 4x minus 16. So on the numerator, we will have 5x minus 4 is x minus 26. I rewrite one more time. X minus 26 over x plus 4 x minus 2. That's less than 0. Now I make a line. Positive infinity. We know that we have that two restricted value, and also now we have the critical value when x equals 26. That make the whole thing equal 0. So we will have negative 4, 2, and 26. Alright, and this one is negative infinity. We have x minus 26 for the first factor. The second one is x plus 4, and then x minus 2, and then the result. Alright, and negative 4 is undefined. Now at 2, undefined. At 26, that makes it 0. Okay, now we can choose the test number. We have less than negative 4 to negative 10. In between the two positive and negative number, I choose 0, 1, 100. Okay, so we have negative 10 minus 26. That is make negative all the way negative. At 0, you have negative, positive, negative, positive. Use x equal 1, you have that negative. You have positive, you have negative. Oh, hold on, this one I use 10. 10 greater than 2, less than 26. So this one will be positive because we have 1 negative. And then this one we use 100. So that will make it positive, positive all the way. Alright, Now we look at the questions. They want less than 0, it means they want a negative reason without 0. So we have negative infinity, comma, negative 4, not use that, critical restricted value, union with another restricted value, 2, comma, 26, not include because they don't include a 0. Number 21. This one we have the restricted value is x different from negative 7. Now we want to move everything on one side and 0 on another side. So 14 over x plus 7, subtract both sides by 2. And now we can find the least common denominator is x plus 7. So we multiply 2 to x plus 7 over x plus 7. That less than or equal to 0. So this one is x plus 7 over x plus 7. Alright. Now we can find it, right? So minus 2x minus 14. So we left with minus 2x. 14 subtract 14, that's 0. So we left with x plus 7 less than or equal to 0. Now we make a line, and before we do that, we find a critical value by x equals 0 because the numerator equals 0 when x equals 0. Now we set the lines up, positive infinity, negative infinity, negative 7, then 0, negative 2x, x plus 7, and then the result. And 7, we have undefined. And 0, x equals 0, the numerator equals 0, make the whole thing equal 0. Now we choose the test point, negative 10 times negative 2, make it positive, negative 10 and 7, make it negative, that's negative. I will choose negative 1 in between the negative 7 and 0, so that make positive, result positive. We choose 1, that negative, that positive, that negative. And for the questions, we want less than or equal to 0. It means it includes a 0 and less than 0, so that negative. So we want open the parenthesis, minus infinity, negative infinity, and then negative 7. Undefined. We want 0. Yes, we want 0, so that's 0, comma, infinity. So in these questions, we already have the all term in one side and then 0 on another side. Also, we have like all the factor form is show up. So it's easy to find what the restricted value is x different from 4. And critical value is the denominator says each factor equals 0. So it will be x equal 2 over 9 and x equal negative 52. Okay, now we can set up the line. Positive infinity, negative infinity. So we have negative number, negative 52, Then we have 2 over 9 because it's less than 1, then 4. Then 9x minus 2, the first factor. The second one is x plus 52. And the third one is x minus 4, the result. And we have that sets up. Okay, negative 52, that is the critical value when here equals 0, this factor equals 0. This one is undefined. Alright, now we try to find the test number to negative 100. 0, 1, 10. Alright, negative 100, negative 900 minus 2. That negative, that make us negative. Okay, 0, we have negative 2. We have positive 52. We have negative 4. We have positive 1. 9 minus 2, make it positive. 1, add the positive number. 1 minus 4, negative. So 10. 90, positive, positive, positive. So result positive. We want greater than 0 or 0. So 0 and greater than 0 is positive. So the result, we have 0 and positive. So this one 0 and positive. Negative 52, comma, 2 over 9. Union, open parenthesis, because 4 at 4 is undefined. So 4 not include. So infinity, close parenthesis. That will be the result. Right, number 23 is similar. We have the restricted value, x different from negative 51, x different from 14 over 9. And then the critical value, that will be negative 17 over 6. We have the restricted value when we know that the denominator have to be different from 0. And then the critical value is when the numerator is equal to 0. Okay? Now we draw the line. Infinity, negative infinity, 6x plus 17, x plus 51, 9x minus 14, and the result. So we have negative 51. We have this one is about negative 3. If it's 18 divided by 6 will be negative 3, right? So it's about negative 3. And then negative 51. So more negative is the 51. That will be on the left side. And then negative 17 over 6. And then the positive number 14 over 9. 14 over 9 greater than 1. So this one will be undefined. The 14 over 9 undefined. 0 at the numerator, make the whole thing 0. Right, now we choose the test number The test number for the first regions is -100. In between the -3 and -51, I choose -10. In between the positive number and negative number, I choose 0. And then we know that 14 divided by 9 is greater than 1, but it's less than 10. So you can choose 10 or you can choose 100. I choose 10. All right. So now -100, -600 plus 17. That's too much negative, right? Negative, negative, make it negative. Now -10, -60, make it negative. Make it positive, make it negative, so positive. 0, positive 17, positive 51, negative 14, negative 10. Positive, positive, 90 minus 14, that will be positive. All right, we want less than 0. Less than 0 mean not include a 0. Less than 0 mean negative. We want negative reason without 0. So the result will be negative infinity, comma, negative 51 not include, union, not include a 0, negative 17 over 6, comma, 14 over 9, close parenthesis. All right, number 24. We have the absolute value inequality. So we remember that we have x plus 9 will be less than 23. And also greater than -23. So we will solve this one by -9 all side. So we will have -32 less than x less than 14. And how we write this one in the interval notation is -32, open parenthesis, -32, comma, 14, close, because it doesn't have the equal sign. So we just use the parenthesis. If they do have like the equal sign, we use the bracket, right? Okay, number 25. So now we just move the 3 on another side and use the absolute values property to solve for the inequality. So that will be 7x minus 8 in the absolute value greater than or equal to 19 subtract 3 is 16. Now we can solve for 7x minus 8 greater than or equal to 16 less than or equal to -16. Alright, now we add all side by 8. We will have this one is -8 greater than 7x minus greater than or equal to 24. Divide by 7, -8 over 7 greater than or equal to x greater than or equal to 24 over 7. Now you see that if we set it up like that, it doesn't make sense, right? Because x less than a negative number. So for example, we represent it here. We will have negative a over 7 here, and x have to be less than that. And also they have x have to be greater than 24 over 7, that the positive number. So it go that way. So it doesn't matching. So this one is the intersections. It mean n. It mean like that. But it doesn't have any in common. It's empty. So this one is no solution. All right, now number 26. We do the same. We keep isolate the absolute value. So 22 and 7, 29. Now we'll set up the x plus a less than 29, greater than negative 29. So we subtract a. We will have this one is negative 37 less than x less than 21. Now this one makes sense, right? So negative 37, yes, less than 21. Number 27. Now we have more work to do, right? So we move all of the object like 22 and then negative 3 right there. So I will be minus 22 from both sides. Left with negative 3, 5x minus 2 less than or equal to negative 27. Now divide both sides by negative 3. Remember, when you divide by negative numbers, this one have to be changed. Alright, so this one will be like that. And we left with 5x minus 2 greater than or equal to 9. Now we do 5x minus 2 greater than or equal to 9 less than or equal to negative 9. We solve for x, so add 2 both, all sides. That negative 7. And then we have 5x 11. So we divide by 5. We have negative 7 over 5 greater than x greater than or equal to 11 over 5. This one doesn't make sense well, right? A negative number greater than a positive number, that's impossible. If we can draw on the line, we can see that here is close. We choose on the left side is negative 7 over 5, and we have to choose like the intersections, right? That's one close, 11 over 5 on that side, and 0 in the middle, if you can see that. So they have no intersections, or they have the empty set for the intersection between two sets. So this one is no solutions. Thank you for participating in this week practice questions set, and see you next time.